Hello everyone, my name is Tasmeeh Ahsan and I'm here to give a presentation on my course called Instrumentation and Control Energy Systems, and my topic for the project is investigative analysis of inductance and capacitance effects on MPPT charge controller output in different locations. And let's move. So these are my topics of presentation: introduction, objective, methodology, circuit design, simulation result, discussion, and conclusion. So this project is actually it's an investigative analytical project where we actually vary capacitance and inductance in the MPPT charge controller circuit to see the voltage output in two different locations, that is in St. John's, Newfoundland, Canada, and Kedah, Malaysia. So these two countries are of two different type of season they have. um, they like Malaysia is a tropical country, whereas basically Canada is mainly compared to Malaysia, it's a non-tropical country. So we wanted to investigate the capacitance and inductance effects that the output of MPPT charge controller have if we vary the inductance and capacitance on a particular irradiation in both winter and summer. So we actually investigated winter season and summer season in St. John's as well as in Malaysia by varying the inductance and capacitance, and we checked the output level. What is the changing in inductance and capacitance have in the output level, as well as we have did some reliability analysis of the MPPT charge controller. So this is about our project, and the objectives are obviously examining how inductance and capacitance affects the operation. This is one of the objective. We explored the impact of varying inductance and capacitance. We see what does it effect have on the output. Then we have to design and simulate the MPPT charge controller using MATLAB Simulink. Then what is the dynamics of MPPT charge controller in different inductance and capacitance configuration, that is the output that we obtained. And then obviously some reliability analysis, that is we find out mean time to failure, reliability and failure rate of the MPPT charge controller. So let's move to the methodology. So the first thing is we have to definitely design the MPPT charge controller in Simulink, MATLAB Simulink. Then we did the comparison between St. John's and Malaysia, and then we tried to provide a modified MPPT controller design that can actually vary capacitance and inductance based on reference value, and we did reliability analysis. So these four are our methodology are done in 4 steps for this project. So this is our design. We can see the solar panel here, the solar panel, the PV, where the sunlights get exposed, and this flows through the circuit. It ultimately, this solar energy is converted to the voltage output. Here we can actually see the reading that we get for the final voltage, and many basic components are used in this circuit, like diode, then There's MOSFET, which is acting as a switching device. The diode is only allowing current to electricity to flow in only one direction, and the PV is responsible for converting the sunlight's energy into electrical energy. And then here is the irradiation reading, the irridance reading, which is tracked PV power. That is, what is the irradiation that is, I mean, being coming. So we can get a reading of the irradiation, which what that we actually kept constant throughout the, like for summer we kept a fixed irridance, and for winter we kept another irridance depending on the geographical location. So this is the overall circuit, and here we are varying the capacitance C1 and L1. So we are varying C1 and L1 to vary, to see the change in the output. And so I explained the operation of MPPT charge controller, and then this is the modified design actually, that after, like, I mean, seeing the variation that capacitance and inductance have, this is actually the design that we are now seeing. This is the control design actually. Here, we can see that there's a controller. This controller actually varies the capacitance and inductance based on a reference value. Say for example, for a irridance of 1000 watt per meter square, we need a capacitance value of 20 farad. So this controller will going to set the value that way, and the feedback value, there's a feedback loop that's continuously giving feedback, and the reference value will going to be there, and the error will be corrected. So the input and output will definitely get some proper value that will perfectly give a output voltage, a proper output voltage. This is the modified block diagram. This portion is one of the portion of the MPPT charge controller. This is not the entire MPPT charge controller. So instead of using capacitance, like manually changing, we can implement this design as a part of MPPT charge controller. We can install it in the MPPT charge controller. And so I have explained the operation of modified design. And so let's move to the simulation result. So this is the result for obtained in St. John's. The top graph is power output versus inductance. And so we can see that with increase in inductance, the power output actually decreases. Inductance, the high output is obtained. Yes, high output is obtained within the range from 0 to 2.5 Henry. We can see a increase in peak, but after that it decreased. However, in when it comes to capacitance, that is power output versus capacitance in St. John's, we can see that the output actually, this does not give any straightforward result like the inductance, because here with increase in capacitance, the graph actually initially fluctuated in the range 0 to 0.2 farad, but then it dropped, and then again after 0.3 farad it increased, and then again after 0.4 it decreased. So it's not a normal result. So we can actually not rely on the capacitance value basically when it comes to St. John's in winter time. Then let's go to the summer. So so these are the explanations that I have done, and our irridance value in winter was 2720 watt per meter square in the St. John's, and this is the result obtained in summertime. And we can see that the power output versus inductance graph, it shows a increase linear relation. So that is, with increase in inductance, the power output will continuously be increasing, and it actually exceeds the limit of 12,000 watt when the value of inductance is 0.14 Henry. Whereas, as usual in capacitance, we see that the result is actually fluctuating previously. So inductance varying is a stable thing. I mean, if I would prefer that, and my suggestion is that whenever inductance is varied, we can get to see a change in output in linear way, or a non-linear, or like it can be in an increasing manner or decreasing manner. However, in capacitance, it does not give any sort of linearity. It's unpredictable for the capacitance, whether it's in winter time or summer time. So let's see the result. These are the explanations that I have done, and in summertime the irradiance was 7320 watt per meter square in the summertime in St. John's. And so in simulation results in Malaysia, Kedah, Malaysia, where we can see the output versus inductance graph, and this one also shows a linear increase in inductance in the winter time. Whereas for in St. John's, we have not seen a linear increase, whereas in Malaysia in the winter time it is showing a linear increase. And here the capacitance graph is bit decent compared to St. John's, because it is showing almost constant reading in the output with increase in capacitance. So I would say that by varying inductance, power output will increase in Malaysia as well as in St. John's. So inductance is very good parameter that can be changed if we want to change the output. However, capacitance does not play an important role. So let's move on to the summer time, and 7470 watt per meter square in the winter's irradiance value in Malaysia. So this is the summertime graph power output. So as usual, inductance is showing a linear increase. With increase in inductance, the power output increases, and capacitance graph is giving a constant, almost constant, with increase in capacitance. So we can actually neglect the variation of capacitance in Malaysia, because it does not actually affect anything in the output. In St. John's also, we can actually in the capacitance actually does give some readings in the output. Value actually doesn't depend on the capacitance in St. John's or in Malaysia. This is one of the most important part, that inductance plays a role. So this is about the results that we obtained, the simulation results. And 6030 watt meter per square was the irradiance value that we have kept constant to obtain the results of Malaysia. And then moving on to the simulation result of the reliability analysis. So we can see that our basically, this is the first graph is the probability density function of MPPT charge controller, and our maximum obtained probability density function is uh, around 2, more than 2, and the operation range is it's scattered from 0.6 to around 1.6, whereas the maximum probability density function is obtained in the range of 1 to 1.2 watt. And this is the right side graph with the cumulative density function graph. We can see that power output increases, and there's also increase in the cumulative probability with the increase in power output. And then let's move on to mathematical result that we obtain. The mean time to failure, it is around 2, we can say that it's 2 lakh 16, it's around 21,666.67 hours is our mean time to failure of the MPPT charge controller, whereas reliability rate is very high, that we have just observed that the reliability rate is 0.99, like it's very highly reliable, whereas the failure rate is 0.00046 per hour, which is very negligible compared to the reliability rate. So these are the parameters that obtained. So it is highly reliable, we can say, our MPPT charge controller. So moving into discussion, uh, as discussed, we can say that finally that we can actually ignore the capacitance part in the St. John's, because it's not giving a good result. The reason is capacitance create noises in the MPPT charge controller, but inductance does not do that, for which the output is actually dependent on our basically our, so that we can say that our output is mainly dependent on the inductance. When varying inductance, the output have an impact, but the capacitance itself creates some noise, and it is not responsible for basically any changes in the output. So these are the main reasons. But and also in Malaysia, we have seen that inductance plays an important part in the variation of the output, whereas capacitance showed very negligible fluctuation. So because same reason, because in MPPT charge control circuit, capacitors role is not to vary the output, but to does not, its main role is not to allow bypass flow of current and some other things to okay, so it does not actually and also to reduce noise of the circuit, but it cannot actually provide a stable output the way inductance does. So inductance have good impact on the output. By varying inductance, we have seen that a very high output can be reached, but if compare with Malaysia, Malaysia gives the best result compared to St. John's. Malaysia is giving best result in inductance. So, and reliability analysis, we have already seen that our basically it's highly reliable, and with standard deviation 2164 watt, and basically the probability density is 2.25 in 10 to the power minus 4. This was highly reliable. Our project was highly reliable with a high reliability. And these are the reliability parameter. Once again, we already discussed the reliability parameters. The reason for MPPT charge control's high reliability is depends on its circuit mechanism. So wrapping up with conclusion, so we can say that our inductance is the game changer in this project. So varying inductance does give actually a good result. However, many other parameters can be brought into consideration to check the output, and so basically careful adjustment in the inductance and capacitance is essential for optimizing the solar system performance, and we have to also focus on reliability parameters as well. um, but the capacitance is must be made sure, because sometimes with varying capacitance we see that in St. John's the result varied, so we have to give a proper value of capacitance to make sure the circuit works properly. So obviously adjustment in inductance and capacitance is needed. and also we have to focus on the parameters, reliability parameters. So this is our presentation. Thank you. Any questions?